So here we're going to start moving on to a new form of angle. And one of the new angles that we're going to be talking about is a inscribed angle. And an inscribed angle is an angle that's created by two chords. And when we're talking about an inscribed angle, like central angles, it has a relationship to its arc. So an inscribed angle is half of the measured arc. So if I come over here and I'm looking at that first problem right down below it, we're looking for the measurement of angle VXW. So we're really looking for this angle at X. And we see that we have two chords. One's a diameter and one's a regular chord. And it creates an angle at X. So we're going to have an inscribed angle. And an inscribed angle, we said, is half of the measured arc. So we have our arc VW. Remember how that little arc right there above VW means that we're talking about the arc of V to W. And that arc, whatever the measurement of that is, we're going to take half of that quantity. Similarly, we already talked about this, but a central angle is created by two radii, and the central angle is equal to the measured arc. Well, what does that mean? Well, we have two radii, which are created at M, and where the vertex is at the center, like we talked about in our last definition from the video before. And we see, since we have two radii, we're going to have a central angle. And since we are now looking at the measure of arc L to K, and since we have a central angle, the measurement of the arc LK will equal the angle M. So, let's put this in action though. Here we have the problem, that very last problem on the left-hand side. What is the measurement of arc BA? Well, the measurement of arc BA, we see that BA has a central angle of 50 degrees. Therefore, this angle here at BA, or the arc from B to A, is also going to be 50 degrees, since we have a central angle. Now we're looking for the measurement of the angle ACB. The measurement of angle ACB, well, we have an inscribed angle. From C to A is a chord, and from B to C is also a chord. So if we have an inscribed angle, that means that it has to be half of its measured arc. So half of 50 will mean that our measurement of our angle is going to be 25 degrees. Now I want you guys to practice this. Go back to the video. This is probably one of the harder questions you'll see. But just know that the inscribed angle is half of its measured arc, and that the central angle is equal to its arc. Alright, so we've talked about inscribed angles now, and now we're going to use inscribed angles to find the arc measurement. So just like how we do with central angles, we can also use inscribed angles to be able to find the arc measurement, meaning the length of the arc. For this problem, we're going to be looking for the arc length of W to X. So just like when we're finding the central angle, we first need to find the circumference. So the circumference of the entire circle, so the distance around the circle. And since we're given the diameter, it makes the most sense to use pi times diameter. Now we can also use 2 pi r by dividing our diameter by 2, but I think it makes the most sense to use diameter here. So pi times 20 will give me what value? Well, put it into your calculator. Pi times 20 will give me 62.83 centimeters. Sorry, not even centimeters. Ooh, a little rough one for me right now. Inches. So we got to be careful with our units. Even I make mistakes sometimes too. Arc measure of XW though, if we're talking about the arc measure of XW, we're talking about the measurement of that curve right here. So, if we have an inscribed angle of 48, we need to double it then, because we know that the angle is half of the arc. So if we're trying to go backwards, then we really need to double it. We need to double to get the arc measure. So if that's the case, the arc measure of XW is going to be 48 times 2, which is 96 degrees. Now we have all the information we need to solve for an inscribed angle. So, if we have the arc measure, which we saw was 96 degrees, we're going to put it as the ratio of our arc measure divided by the whole measurement, which the whole measurement is the whole measurement of the entire circle, which is 360. And that is equal to the arc length. We don't know what our arc length is. It's what we're solving for. So I'm going to say it's x. Now we need to put our ratio of our arc length divided by our circumference, which our circumference we saw was 62.83. Just like how we did before, we're doing a cross multiplication. So 96 times 62.83 is equal to 360 times x. Now we have the information that's needed. We can now solve. Like we did before, we want to solve for x. We want x to be all by itself. So, if we're doing 360 times x, we got to remember, the inverse of multiplication is division. So, if we're going to do divide, we're going to divide by 360. 360 on both sides. That 360 divided by 360 turns into a large 1, so it leaves us with 1x. Then we just do 96 times 62.83 divided by 360. That gives us our x to be equal to 16.75 inches. Now that is our final answer, and we'll be able to solve from there. Now there's another question for you guys to practice on your own. Try to use this one as a model. It's very similar to the last problem that we just did all together. Now it's your turn to practice.